friends, students, and enthusiasts. So today, very important for the project learners, especially the beginners who want to start with new projects or want to build a new project. So for electronic project or electrical project, the 555 IC is the very good IC to start with, for learning purpose, for making some projects related, so that you get confidence. So to start with, you should start with 555 timer with sensor. So building and learning using 555 timer and different type of sensors, right, with the help of a breadboard diagram. So what we're going to do in this, you can see on your screen some 5-6 names I've given. So all those projects we are going to make maximum with a single circuit. Please remember, 555 IC with a single circuit. We are going to make all this just by changing the sensors. Maximum one. Okay, so let's begin with the circuit and the other details. The working principle of the circuit is, let's say, raindrops, IR light, or any type of a sensor which will be using some light will be falling on that sensor or something like that. Sensor module output becomes low or high. That is the idea. The module output will become low or high. Let it be analog or digital. So modules will give you low or high depending upon module type. So on basis of this, you have so many sensors like PIR sensor, flame sensor, then you have light LDR sensor, proximity sensor, and so many other sensors are there. So using those sensor, we will use those sensor and we will make it high and low, the output. The trigger 555 timer, it will be triggering the 555 timer, and output will drive the LED buzzer or a relay. Okay, LED buzzer or relay, that we will see in this thing. So what we have done is, here one more important point I would like to tell you about this is, here for timing calculation, I will explain you when we go there. In the timing calculation, like suppose you want that the light should be on for so much time, or the buzzer should be on, or the alarm should be on for so much time, we can adjust it with the help of the formula, that is T is equal to, that is time is equal to 1.1 into R into CT, or CT is equal to 1.1 into R into C. So here we have used resistance as the 100 kilo ohms and capacitor as 10 microfarad. So approximately it will come to 1 second. That means the sound or the light will be there for 1 second. So please remember this timing calculator if it is necessary for our circuit. That I will going to show it to you. So what are the components? We will require any 555 IC. It is a 8-pin, simple 8-pin IC. That is, we call it as a timer IC also. We need a breadboard sensor module. You can take any of the sensor module. I've named it different type of sensor, analog type or digital type. I've used one BC547 transistor since it will drive the buzzer, LED, as well as your relay. So that's why this transistor I've used it. 10 kilo ohm resistor, buzzer is there, 100 kilo ohm resistor, 10 microfarad capacitor, electrolytic, LED, 330 ohm series resistor, battery, and jumper wires. These are our requirements. All right. Okay. So this will give you the idea. This is the schematic diagram, a rough diagram. This is the IC. I've used one sensor over here. So replacing this sensor with different sensor, I have kept it here. You can see different sensors. You have this thing. This is not a sensor. Of course, this is a relay. This is one sensor, LDR. This is touch. This is your moisture sensor, rain sensor, gas sensor, proximity sensor, and flame sensor. So using all this sensor in this place, that is the circuit will be same. Mind, only you have to replace the sensor and you will get output on the buzzer. This is our buzzer and this is our LED. So, okay. So this is our project. The battery is over here. 1 kilo ohm resistor for the output, 100 kilo ohm resistor. If you want, you can use a variable resistor here or fixed value resistor. If you use variable resistor, you can vary the timing as well as you can change you can vary the capacitance value also. Okay, this capacitance value also you can vary, because this resistor and this capacitor will give you the adjustable time. Okay, it will adjust the time, or we call it the delayed timer. Okay, so we will see this also, and we will go to our we'll directly jump into our project. That is, I will just show you on the breadboard so that you will understand fast. Lab, small circuit, as you can see on a small board I have made it. So I will explain you about the basic circuit. This is very simple circuit. So first of all, the IC, 555 IC. So pin number 1 is connected to ground, and pin number 8 and pin number 4 are directly connected to supply. Whatever supply you're paying, 4 volts, I've given a 4.2 volts or 3.7 volts from here. And you can use up to 9 volts also, no issues. Okay. So I've taken 4. Why? Because I'm giving the same supply to this, the sensor also. So I've used a lesser supply. This is here. What I've done is pin number 2 is the output, that is going through a 1 kilo ohm resistor to the base of the transistor. This is NPN transistor, BC547, and the load is connected on the collector. So collector is one end is connected to the negative of the buzzer, positive end is connected to one end of the LED, and another end goes to the supply, directly to supply. So positive of the buzzer goes to the cathode of the LED. Okay, so this is the arrangement of the transistor. Emitter is grounded. Again, instead of using 100 kilo ohm fixed value resistor, what I have done is I have used 100 to 100 or 200 kilo ohms variable resistor here. Okay, that I have connected to pin number 7. Two ends are ground, or other you can put it through any of the resistor. So I have put 100 kilo ohm resistor, and this is 200 preset. So that is this thing. Pin number, one more important point, pin number 6 and 7 are directly shorted here. You can see here 6 and 7 directly shorted. Okay, and one end goes to pin number 7. Two end of the variable resistor are connected together. As you can see, this is the jumper which is connected together. All right, so I will just show you how it works. So supply is there. I have used a proximity sensor, that is IR sensor over here. IR sensor. This is my IR sensor. So maximum time we will use IR sensor, and I will just show you if any intruder come, how the alarm works. So I'm just putting my hand. Some intruder is there. It will come for some time and it will go away. So it was there for a longer period. I can increase or decrease the time with the help of just moving or changing the value of this thing. Okay, you can see. So it went a little faster. So if I increase the value, I can change the timing. At the same time, if I decrease the value of this capacitor, now it is 10 microfarad, I can change the value. So just see, this is one. Okay, so what sensor I have used? I've used IR proximity sensor, which has a transmitter and receiver together in a complete PCB setup. Okay, so this is the simple circuit with this thing. I will show you with another sensor module. Here I have changed the module. You can see this basic circuit is same. Please remember, this basic circuit is same. I have changed this module, and while changing the module, please remember supply, ground, and analog or digital output you should be very comfortable with it. That means it should not be wrong. Okay, so here I have used a raindrop module. You can see rain drop module. I will show you the example. Okay, so I'm taking a little water. Suppose the rain is falling. You can see when rain is there, when I'm making this thing, then it will give you buzzer. When I remove this continuously, it will go off. Again, you can watch it. Right? So this is you can make a rain. That means a sensor, when the rain comes, it will tell you that to the outside the rain is coming. Okay. So I have removed the water now. So this is one project. Only the difference is I have used a sensor. Okay. So I've taken a digital output of this sensor. In other case, I can take analog also, but here I have taken the digital output of the sensor. Okay. So one more thing I would like to tell you, pin number 4 of the IC, I have connected 0.01 capacitor, which is going to go to 0 this thing. This will make the circuit a little sensitive. Okay. So that's why this capacitor is also important. All right. So I will go for another sensor. Circuit will be same, the sensor will be different. Now I have used another sensor. This sensor is flame sensor. Okay, this is a flame sensor. So let's try with the flame sensor. Circuit is same. Please remember, the circuit is same. You don't have to change the circuit, only plus minus and output you have to take. So I'll just bring flame together. Right? Okay, you can see this thing also, or I will try to show you the buzzer sound also. I will just try to give you the buzzer sound so that you can understand. I will try to put a buzzer sound also. You can understand this. Okay, so likewise, it works with the flame sensor also. So we have changed the flame sensor here. Okay, now we'll try with some other sensor. Okay, the sensor what I have used is soil moisture sensor. Just imagine this is a soil there is inside, but I'm just for this purpose, I have taken only water. So these electrodes, when I put it inside the soil, if this dry or wet, that is the main indication. If it is wet, then this light will come. If it is dry, the light will not come. Okay, so I'm just putting this into the water. So light has come. You can see light and buzzer, both the things have come. I have removed it. It is a dry condition. So we can use same circuit. We can use a soil moisturizer sensor also. Okay. So now what I have what I have done is with the soil moisture, I have connected a relay. That means when the side it is dry, that means when the soil is dry, at that time the motor should start and it should irrigate. That means the water should be falling on the soil so that the moisture level will decrease. So that is I have connected a relay. On the other side, we can connect a motor here. I have not connected a motor. Circuit is same. I just wanted to give you a demo. That's all. So what I'm doing is if it is this thing wet, you can see the relay has started. Okay, relay has started and the buzzer and everything has started. We can reverse this also. Okay, we can reverse this also. That means by using another transistor, we can positive to negative, we can change it. Okay, that means the timing we can change. Of course, the timing, delay timing, the run time, and we can, as we have already discussed, we can use this by changing the value of the resistor and the capacitor. Okay, please see. So the green light has come, green light has gone. That means the relay has started and relay has, oh, it is working and it is not working. You can see here. Okay, so this is the project where we have used relay also. That means we can control also. We can control the motor also. All right, friends. So we have changed now to a gas sensor. It can be any type of gas, ethane, methane, propane, butane, or any type of gas can be there. So you get different type of sensors. I have connected. The circuit is same, and I will just try to show you here. Okay. So I've taken a lighter from where I'll try to put a gas on this, and let's see what happens. Okay. So let's see what happens. I will see the gas level has come and there was a light. When the gas level comes down, this thing at the same time, you please this thing also gets high. That is the relay. The cutoff will also get. So that means you can see the light. It will stay down for unless the gas level comes down. Now it has closed. Once again, we'll check it. It has come. Okay. At the same time, this also came up. Okay. So these type of projects, you can do it with the help of 555 IC. For beginners, learners, how the 555 IC works, stable, unstable, monostable, both the things you can try, and you will get so many projects with the help of this. And finally, we have used one more sensor. That is the final sensor, that is touch sensor. Okay. So the connection you have to check, that is plus, minus, and output. Okay. So what I will do is I'll give the battery connection and I will check. So continuous light is coming, the buzzer is coming, and the relay light is also coming. That is the relay on. So here it is a reverse, if I give a touch here, it stops. Okay, everything stops. As soon as I remove my hand, it will give you buzzer. So you are controlling with the help of this. I can reverse this also. You can reverse this also. I told you with the help of a transistor, I can reverse the program. Okay. So this is the use for home automation and all, and touchscreen displays and all. You can use it with the same basic circuit, that is 555 circuit. You can change the time and you can control the appliances by changing or by using different type of modules which I have shown it to you. I hope you will understand. If you have any questions to be asked, then please let me know, or please write in the comments so that I can clear it up. Okay. I hope you like this video. If you have liked this video, please share with your friends and please do try in the summer vacation. This is a good learning videos. Thank you for watching. See you next time.